In the 1940s, while the world was engulfed in the shadows of war, the scientific community was writing its own chapter in history. Today, we'll delve into one of humanity's most significant yet controversial projects, the Manhattan Project. Was the birth of the atomic bomb a groundbreaking scientific achievement, or a dark turning point that disregarded ethical boundaries? Let's explore these questions together. World War II, one of the most devastating and extensive conflicts in history, affected millions of lives. During this war, the U.S. government launched the Manhattan Project to develop an atomic bomb, aiming to gain a decisive advantage over its enemies. This project not only marked a significant scientific achievement, but also sparked ethical and humanitarian debates. Background of the Manhattan Project. In the late 1930s, reports of Nazi Germany advancing in nuclear technology compelled the U.S. to act swiftly in this field. Scientists like Albert Einstein and Leo Szilard sent a letter to President Franklin D. Roosevelt, warning of the possibility that Germany might develop nuclear weapons. This led to the official launch of the Manhattan Project in 1942. The primary goal of the project was to harness nuclear chain reactions to create a powerful explosive. Initial research was conducted at institutions like Columbia University and the University of Chicago. However, the main base of the project eventually became the Los Alamos Laboratory in New Mexico. Scientific foundations of the project. The foundation of the atomic bomb lay in nuclear fission, where the nucleus of an atom splits into smaller nuclei. This process, involving uranium-235 or plutonium-239 atoms struck by neutrons, releases an enormous amount of energy and triggers a chain reaction. The success of the Manhattan Project depended on turning these theoretical concepts into reality. To achieve this, massive facilities were established in Oak Ridge, Tennessee, and Hanford, Washington, to produce enriched uranium and plutonium. J. Robert Oppenheimer and leadership. The scientific leader of the project was theoretical physicist J. Robert Oppenheimer, often called the father of the atomic bomb. Leading the project, Oppenheimer faced not only scientific but also logistical challenges. At Los Alamos, scientists from various disciplines collaborated to accelerate the project's progress. However, Oppenheimer had to confront ethical concerns alongside scientific obstacles. The Trinity Test, the first nuclear trial. On July 16, 1945, in the Jornada del Muerto desert of New Mexico, the first nuclear bomb test, known as the Trinity Test, was conducted. Scientists feared the explosion might ignite the atmosphere and destroy the entire planet. Fortunately, this did not happen, and the test was successful, producing a more destructive force than anticipated. The explosion released energy equivalent to 18,000 tons of TNT and created a mushroom cloud 12 kilometers high. This event showcased the devastating power of nuclear weapons for the first time. Hiroshima and Nagasaki. Turning points in human history. Just weeks after the Trinity Test, the U.S. decided to use atomic bombs to force Japan to surrender. On August 6, 1945, Hiroshima was bombed, followed by Nagasaki on August 9th. The little boy bomb dropped on Hiroshima claimed over 140,000 lives, while the Fat Man bomb dropped on Nagasaki resulted in more than 70,000 deaths. These bombings led to Japan's surrender, ending the war, but also marked the beginning of unprecedented destruction in human history. Ethical debates and responsibility. Following the Manhattan Project, the development and use of nuclear weapons ignited intense ethical debates among scientists and policymakers. After witnessing the bomb's impact, Oppenheimer famously stated, "Now I am become death, the destroyer of worlds," expressing his regret. The development and use of the atomic bomb exemplify how scientific curiosity can push the boundaries of ethics. This raises questions about whether scientific progress should always be pursued, regardless of its potential consequences. Scientific contributions of the Manhattan Project. Despite its controversial outcomes, the Manhattan Project made significant contributions to science. It advanced nuclear physics, materials science, and engineering. Techniques developed during the project are now used in energy production, medicine, and even space exploration. The Cold War and the arms race. The success of the Manhattan Project fueled an arms race between the US and the Soviet Union. During the Cold War, both sides developed more powerful nuclear weapons. During this period, nuclear deterrence strategies played a crucial role in maintaining global peace. The balance between science and ethics. The Manhattan Project is one of the most striking examples of the power of scientific knowledge and its profound impact on humanity. It highlights the importance of balancing scientific advancement with ethical responsibility. The development of the atomic bomb serves as a reminder that scientific breakthroughs intended to advance humanity must consider their ethical and societal implications. The debates and scientific progress following the Manhattan Project provide essential guidance for using future technological innovations responsibly and consciously. The Manhattan Project is recognized as one of the greatest scientific accomplishments in history, but its consequences remain deeply debated. The nuclear age it ushered in not only revealed the scale of destruction, but also taught us the importance of wielding scientific power with care. Science enables progress, yet when ethical responsibilities are overlooked, that progress can become a threat to humanity. Our journey ends here for today. What do you think? Where should science draw the line? Share your thoughts in the comments below. See you in the next video.